Data virtualization meets those challenges because it was built to sort of federate data. It was built to play with different types of data sources in mind. Even if you go back in time, if you go to the first version of Denodo, even if you go back to the first versions of data virtualization products we had, the goal was always data is stored in, let's say, a heterogeneous set of systems. We now have to bring that together, integrated live and on demand. That's where data virtualization comes in. A lot of companies are now on the road, let's say, to go from on-premise to cloud, right? Almost no one now has all the data in the cloud. We still have a lot of the data on-premise, but that means that every time when we move data from one place to another, from on-premise to cloud, it can have impact on all the applications that we have, on the reports that we have. We may have to change them, we may have to change code. And I think you are touching there on one of the key features of data virtualization, which is what you could call abstraction, to sort of hide where data is stored. So if you sort of slide a data virtualization in between your data users and, let's say, your data sources, it will be much easier for an organization to move data off the from on-premise to the cloud without having to impact the reports that are up and running. And we can even do that little step by little step. We don't have to do it in one go to sort of move an entire system from on-premise to the cloud. So in a way, data virtualization helps us to make that migration to the cloud in a more seamless way.